G'day guys, my name's Felix, I'm from Electrotech Solutions. Today I'm going to be running through the SWP, or the Safe Working Practices, which is one of 3 exams required for your LEA. It's generally the first one people do. There's quite a few steps involved to be able to do this safely. And you know, I just like to tell guys that I tutor to think about it practically and put yourself in a proper working situation. And try and do the things that you'd normally do at work into this exam. And that would include introducing yourself to the customer. So out on the job, you wouldn't just turn up and get straight into working. You would find the responsible person, the homeowner, supervisor, whatever that might be. Have a chat to them about what you're doing, why you're there, what work needs to be done, you know, what appliance needs to be repaired. They'll give you all that information. You need to check whether there's any essential services on the circuit. You know, and this is quite important because at some point later on we're going to be turning circuit breakers on and off. And the last thing that we want to do is interfere with any sort of essential services or anything of the like, or any other situation that we might need to be aware of. There's an important thing first up. You need to understand you've been called to a job where there's a fault, and along with that there may be the potential to be stray voltages. We don't want to go ahead and start touching anything before we establish whether there's any stray voltages or anything that can be harmful. When you get into your exam, you'll be given a known earth, so you'll be told where there's an earthing point, but in the real world you'd want to establish a trailing lead into a known earth. So you can establish that you can work safely. Okay, so I'm going to say this is my known earth, and you'll test to your frame in 3 spots. Now, although my tester just showed that there's no voltage present, we can't be 100% certain that my test is working or functioning properly. So we will need to test our tester on a known live source. So you'll find somewhere a known live source where we can go, we have active, neutral, active earth, neutral earth, and establish that yes, my tester is working fine. So I've tested the frame, there's no stray voltages, I've tested my tester, I know that's right. So in theory, we should be right to touch this and start to work on our appliance. Okay, now that we've done that, as I say, we are going to be doing some work, and we want to let people know as soon as possible that we're going to be working on these circuits. So we can put some danger tags on, and we write our details on there, our name, the company we work for, phone number, the date, any other relevant information, and we'll put it down at the appliance too, the appliance that we're working on. Okay, and this just protects us. So now that we're actually into the disconnection, we can test our tester, active, neutral, active earth, neutral earth. Once we've established that, we can remove the cover of our appliance, and we're going to test our appliance. To do that, we're going to do it from our earth to active, earth, neutral, and then actually between the conductors, active, neutral, active earth, neutral earth. Again, this just showed that there is voltage there. I'm not going to take any chances. I'm going to just test my tester and make sure this step isn't necessary, but it's something that I like to do. That every time we test the appliance, get into the habit of putting the cover back on. We're going to go to our known live source. Now, there's a chance that this known live source in the real world could be in a separate room. So every time we go to our known live source, put the cover back on. When you're out in the workforce, you're not going to leave exposed covers while you walk off and do other things. You know, it creates a really big potential for a hazard. So test our tester, active, neutral, active earth, neutral earth. All good. Okay, so we have power there. What I like to do is start from the first circuit breaker. So we need to isolate this appliance to be able to work on it. So we turn the first circuit breaker off. we put on a lock dog. So every time we turn a circuit breaker off, we lock it out. Whether we've established yet it's the one that we need or not, we're going to be removing the cover, we're going to be working on an appliance. The last thing we want is for someone to come and turn that circuit on, bringing the key with us. We're going to test our tester. Active, neutral, active, earth, neutral, earth. We're going to remove our cover. We're going to test from our earthing point. Active, earth, neutral. And we're going to test active, neutral, active, earth, neutral, earth. That shows that there is still power connected. Again, I'm going to put my cover back on. This step isn't necessary, but I'm going to test my tester again, because again, I'm going to get into the habit of every time I test, I'm going to retest my tester. Active, neutral, earth, neutral, earth. We'll remove our lock dog. That's obviously not the circuit that we're looking for. So we will then move on to the next circuit. Lock that out. Padlock on. Again, remembering to take the key with us. Now we've just tested our tester, so we don't need to test it again. Remove the cover from our earth point. Active, earth, neutral. Active, neutral, active, earth, neutral, earth. Again, this has come up as there being no voltage, but we can't take that as a given, because we need to retest our tester to make sure that something hasn't gone wrong with our tester in the meantime. Active, neutral, active, earth, neutral, earth. Now I'm happy to say that that is the circuit. This appliance is now isolated, and we can continue with the removal, the disconnection. Once we've done that, it's a good idea to come and have a look at your board. We're going to cable tie this on. We're going to draw a diagram of our circuit board, so that when we come back for the reconnection, we can establish that we've got the right circuits that we're working on. 20 amp, C-curve, circuit breaker number 2. We're also then going to draw a diagram of the connections before we disconnect them. But we're going to get some vital information. Maybe the make, the model number, the rating of the appliance. And we're going to draw a little diagram with the terminals. And it's going to show where our connections are being made. Active, earth, neutral, so on and so forth. And keep that handy. Okay, now that we have our diagram, we can start by removing the conductors. Let's remove them, starting with the active. Being careful not to touch that copper onto the frame, because it can cause RCD to trip, regardless of whether it's on the whether the circuit that we're working on is live or not, between neutral and earth. Next, we'll disconnect our neutral. If you notice, when I tape, I like to leave a folded over tab. This helps with finding the end of the tape later, and it might seem a little fickle to do so, but when you're dealing with it every day, trying to find the end of tape can be like the world's worst job. So, you know, we've got a tab there that can't get stuck down. It's easy to find later. And disconnect our earth. Again, tape. Creating a little tab. And these conductors are right to remove. Now, all this conduit work should be all glued in. So we can't just simply pull the corrugated out. Bring this out. And we're going to get our junction box. Into our junction box. Lid on. Diagram in. Ready for the reconnection later on. Do our screws up. And this should be secured somewhere out of the way with a cable tie or something of the like, just to help give it that little bit of extra mechanical protection. We don't want to have this floating around somewhere that it can be getting damaged. Put your cover back on, because you don't want that getting lost. You may need it if this appliance gets repaired rather than replaced. We don't want to be searching around for screws and that type of thing. And we're going to tidy up our area as you would normally do. Get ready to leave. Let the supervisor or the homeowner or whoever it might be know what's happening and that their appliance is disconnected and ready for their repair. And they can give us a call ready for the reconnection. Okay, so we've been told that the appliance has been fixed, repaired. We've just carried it back in, we've screwed up, we might have done whatever that might need to be done. It's not necessary to test the frame now, because if you remember we said that at the start we didn't want to go touching anything before we checked for stray voltages. In theory, we've just carried this in, there's no electrical connection, so the book says that we don't have to test it. I don't completely agree with that. What happens if we've screwed this back to the wall? There's a cable behind it. It's we've drilled into an active. We've screwed into it, and now the frame's live. So I think it's important to test our tester, test our frame again, retest our tester, and we can really definitely 100% establish that. There's no stray voltages. Now that's not necessarily in the exam, but it's something that I like to do. Okay. What I like to do now is just get our diagram out, just so we can have a look at the switchboard and the appliance and make sure it's it's been replaced or repaired with exactly what it needs to be. So we can check our diagram. Yes, the switchboard looks fine. Yes, it looks like the same circuit. And the appliance, have a look. The appliance has been repaired, or if it's been replaced, it's been replaced with something that's like for like. Okay, so we've established that, and that all looks good. Okay. We need to make sure that this has been repaired or replaced with the proper equipment, and it's right. And in order to do that, we're going to do a mega test, or an insulation resistance test. First off, we're going to test the battery in our mega. Battery showing it's good. And then on the 3 ohm scale, we're going to zero our meter. Now this is quite a way off. We're going to get that down to 0. Looking at it the way I am is not exactly correct. You want to be directly over the top of the meter, looking straight down at it so that we don't get any variance. So I'll just pop that down to the table and have a look, and I've got that exactly down to 0, so I'm well happy with that. Alright, on our 500 volt scale, we're going to do an insulation resistance test on the appliance. We're going to test from active to earth, and we're going to test from neutral to earth. Okay, and what we're looking for is a result that is as high as possible. But in theory, it needs to be greater than 1 megohm or 1 million ohms. Unless it's an appliance that has a sheathed element, then it can be 0.01 of a megohm or 10,000 ohms. Yeah, this is an important thing to remember because those type of appliances with a sheathed heating element can store a bit of moisture in them. Hence why there's a little bit of variance there to be able to have that little bit of insulation resistance being slightly lower. The other thing we need to check is the earthing system of our appliance. So from the earthing terminal to the stud, on the 3 ohm scale, we want this to be down to 0. Scratch the paint, make sure you get right down into the middle of the frame. Okay, and I'm happy with that. Retest our mega to make sure that that is all working properly, that nothing's changed in between. So let's zero that down. Check our battery. 3 ohm scale, down to 0, perfect. Okay, so I'm happy with how this appliance has been repaired. Next, we're going to open up our junction box. We're going to test that our conductors are still dead. Test our tester, active, neutral, active earth, neutral earth. And then from our known earth, what is going on there? From our known earth, we're going to test each conductor. So we're going to go from our known earth, we're going to unwrap and test our active. Unwrap, test our earth. Unwrap, test our neutral. And then we're going to test between each other. So leave the neutral unwrapped. We can then re-unwrap the earth and test from neutral to earth, re-wrap, neutral to active, re-wrap, active to earth. And again, this is showing no voltage present, but we can't take that as being correct until we have tested our tester again to establish that it is still functioning correctly. So, cover back on. Active neutral, active earth, neutral earth. Our tester's working fine, so that's dead. So now we've established the appliance is fine and working. The cable that we need to connect into it is dead and not live. Take our junction box off. Plunge it back on. And we can reconnect them in one at a time. Starting with the earth. So we want to establish that protective earth as soon as we can. Then the neutral. Then the active. Okay, those connectors are now back in. Now that we've done that, we also want to test our protective earth, and that it is now connected to the greater mass of earth. So using again our trailing lead or our known earth, we want to test from the appliance to our known earth. Okay, we'll test that We want that to be as close to 0 as possible. Really, it should be 0. But there is a table in AS 3000, table 8.2. If you go to your R of your Earth, or your resistance of your Earth, it'll give you the maximum allowable ohms according to the breaker size and the cable size. I've established that that is fine. Okay, test your meter again. Make sure it's down to 0, which it is. And we're going to put the cover back on the appliance and get ready to re-energise. Okay, we can remove the padlock and our lock, and we can re-energise. And it's fine to re-energise now. We've tested the appliance. We've tested the earthing system, so if there is a fault or there is anything, we know that the path for that fault current has a low enough impedance to ensure that our circuit breaker would trip. Okay, now that we've done that, remove the cover. We can test from our known earth, active, neutral, earth, and then back at the appliance. Active neutral, active earth, neutral earth. Again, that shows power, so there's no real need to test your tester again. But for the sake of habit, I like to retest our tester. Active neutral, active earth, neutral earth. We can remove our danger tags. We can let the customer know that we're done. His appliance is all up and running. It's all safe to run. You need to fill out your certificates, which need to be lodged immediately. Give them a copy of the certificate, or if it's electronic, let them know that you'll forward it on to them as soon as you receive it back from Energy Safe Victoria. And once that's done, tidy up your area, and you're pretty much all done. And hopefully that helps out some of you guys that were maybe having a bit of trouble with the SWP. We also run courses for your prac and your theory, and also all of your, or majority of your Cert 3 modules. For anyone that's having any trouble, you can pop down. We do it in small groups, sort of help each other out. You guys aren't alone if you're having a bit of trouble with it. So again, that's SWP. I wish you guys all the best of luck.